They called it the hidden fury of the sun, a colossal force hurtling through space, invisible, silent, and absolutely unstoppable. What NASA just revealed could reshape our understanding of life on Earth, future space missions, and even the stability of our planet's power grids. Welcome to Atomic Domain, where deep space meets deep science. Today, we uncover the true power of the solar wind and why what NASA just found out has scientists scrambling. For decades, solar wind was thought of as a background hum of energy from the sun, a steady stream of charged particles that mostly affected satellites and the aurora borealis. But that idea is now obsolete. NASA's Parker Solar Probe, traveling closer to the sun than any object in history, has just revealed something astonishing. The solar wind is more chaotic, more explosive, and far more dangerous than previously imagined. Solar wind is the stream of plasma, mostly electrons and protons, released from the upper atmosphere of the sun, called the corona. It blasts outward in all directions at speeds up to 1.8 million kilometers per hour. Scientists used to believe this was a gentle outflow, like a river of charged particles. But what the Parker probe found is more like a raging storm, filled with sudden reversals in magnetic direction known as switchbacks, twists in the magnetic field that behave like a whip cracking in space. These switchbacks might be the missing link in understanding how the corona reaches temperatures over 1,000,000 degrees Celsius, far hotter than the sun's visible surface. This has been one of the great unsolved mysteries in solar physics. NASA's high-resolution data uncovered bursts of energy and magnetic chaos that resemble turbulence in Earth's atmosphere. That turbulence is key because it suggests that solar wind isn't just passive, it's a dynamic, eruptive force with the potential to affect the entire solar system. This discovery implies that the sun isn't a calm, slowly burning star. It's an incredibly active engine of violent, unpredictable forces. And solar wind may be the mechanism by which that energy bursts out into space. Twisting magnetic fields within the sun snap and reconnect, releasing jets of plasma in all directions. These explosive magnetic shifts were observed in stunning detail by the Parker probe, confirming what physicists had long suspected but could never prove: the sun is far more volatile than it appears from Earth. So, why does this matter? Because Earth is directly in the line of fire. When solar particles collide with our planet's magnetic field, they can trigger geomagnetic storms strong enough to knock out power grids, disable GPS satellites, disrupt airline communications, and even fry spacecraft electronics. These storms also pose serious risks to astronauts and high-altitude aviation. A single massive solar storm, like the Carrington event of 1859, today could cause up to $2 trillion in global damage and take years to recover from. And the data from NASA shows that we may be entering a period of increased solar activity. In fact, we may already be overdue for a catastrophic event. The Parker probe's closest flyby, just 6.5 million kilometers from the solar surface, took it right into the heart of the corona, a region previously unreachable by spacecraft. There, it recorded switchbacks occurring with far greater frequency and violence than anyone predicted. In mere seconds, the magnetic field could reverse direction completely. These high-speed flips create powerful, high-energy waves that transfer momentum and heat, a discovery that could solve the age-old mystery of why the corona is hotter than the sun's surface. This fundamentally changes our understanding of solar weather. The solar wind is not uniform. It's an ocean of turbulence, instability, and chaos, and Earth is sailing straight through it. As a result, NASA is now working with agencies like the European Space Agency and China's Space Weather Center to develop more advanced forecasting systems. Current models based on stable solar wind flows are no longer sufficient. Parker's mission has also revealed something deeply troubling. Switchbacks are not rare. They are frequent, widespread, and growing stronger the closer the spacecraft gets to the sun. This means that space weather events could become harder to predict and more intense over the coming years. And this isn't just theoretical. In February 2022, a minor solar storm caused dozens of SpaceX Starlink satellites to fall from orbit, costing millions of dollars in damages. If a minor event can do that, imagine what a Carrington-level storm could do today. Even Earth's magnetic field, which shields us from much of the solar wind, is not invincible. Scientists are now studying how this field is weakening, especially around the South Atlantic anomaly, potentially making our planet even more vulnerable to future solar fury. NASA's revelations from the Parker Solar Probe are a wake-up call. The sun's hidden fury is no longer hidden. It's measurable, observable, and building in intensity. As we move into a new era of space exploration with missions to the Moon, Mars, and beyond, understanding and predicting solar wind becomes a matter of survival. For satellites, for power grids, and for astronauts, the stakes have never been higher. And here's the truly mind-blowing part: we're still just scratching the surface. Parker is scheduled for even closer passes, flying as close as 6.1 million kilometers to the solar surface by the end of its mission. The closer it gets, the more secrets it uncovers, secrets that could change our entire understanding of stellar physics.
NASA's findings are rewriting the textbooks. The solar wind is not just a breeze, it's a warning shot from the most powerful object in our solar system. The sun's fury is real. And now, thanks to the Parker probe, it's no longer silent. If the sun can do this, what else is it hiding? Subscribe to Atomic Domain for shocking truths behind the cosmos. Like, share, and comment to help the world understand what NASA just uncovered.